All right, so I have started the live stream, but I might need to actually get out and then get back in because I think OBS is lagging significantly in terms of the video, in terms of the webcam. In terms of the desktop, it is not lagging. It's just the video that is lagging. I can turn it off so that way it doesn't cause any problems. There we go. Alright, so, and I am switching back to Discord to monitor the text traffic. So let's go to the text channel of today's date, and that's where I'll be reading because I can only read one text channel at a time. So let's all go to that specific text channel with today's date. Yep, there you go. Excellent. So everybody knows where to go now. In my other classes, I just do the screen share using Discord, but this class is way too big for that because Discord only allows up to 50 people to watch a screen share. So I'm getting a whole bunch of people saying hi. Excellent. I'm glad you guys are here. And we got 5 more minutes before the class starts. You guys can post questions. I mean, since I'm here already, might as well use this time. If you have any questions. All right. And then I'm gonna go check to see if there are any last-minute people who are just adding to the server. Like last minute. Well, not quite last minute. We still have about 4 minutes to go. Yep, I see Aman, A-I-M-A-N, but Aman has not changed the nickname to the actual name on roster, so I'm not changing the role to student yet for that person. And yep, I'm gonna wait a little bit until that nickname is changed. Alright, so when I'm waiting, since we still have 3 more minutes, I'm going to show you guys something that might be of interest to some of you. This is Joplin. And let me zoom in a little bit because it's probably hard for you guys to read it. So this is Joplin. Joplin is a note-taking type of application. That's one of the things you can do with it is note-taking. What is kind of interesting about Joplin is it makes use of Markdown. So over here you can see Markdown, and over here this is the HTML rendering. Oh, I don't really care about the live stream name. I mean, you don't even need to have a YouTube account when you're watching the live stream. It's only when you are on Discord that you need to have your name, because I don't watch the chat traffic on YouTube at all. So so let's not use YouTube for that purpose. Markdown is a play of the name, because what is HTML? What is the M of HTML? It's hypertext markup language, right? So that's the correct use of the term, is marking up something. In other words, it's not plain text. It is a formatted text, so we can have italic, we can have boldface, and so on and so forth. So Markdown is a play of that name because it's a whole lot easier, because the h1 tag is just a hash in front of whatever text you want to be in header 1, and then header 2 is double hash, and then this is just an asterisk, so you don't need to say open bracket ul close bracket, and then each line item has its own element tag, so it's a whole lot easier that way. Yeah, I've heard about Obsidian. I looked it up and it looks about the same. But this one is completely open sourced. I'm not really sure whether Obsidian is open sourced or not. Aaron can probably tell us a little more about that. Alright, so let me check the membership again. And because some people are, I'll just say, optimistic about their timing. There we go. So we got Amon added to the student role. And I'm just scanning through to make sure that I'm not missing anyone. So I think so far so good. And I see one person in the voice channel. I'm not using the voice channel on Discord. It doesn't mean that people cannot get onto that voice channel. It just means that it's not going to help in any way. So now we have 2 people getting on the voice channel. I'm getting some feedback. Oh. Okay, hopefully the feedback is not going to be a problem today. Alright, so I'm looking at the time right now. It is 7:30, so I'm going to get started here. Alright, so a few things. This is Markdown. I'm just keeping an eye on the text channel. The answer is no. I think I have made it. Okay, let me not put it that way. In the announcement, it says how to take the class. I'm really hoping everybody gets a chance to read all of the announcements, because I'm pretty sure in one of the announcements I said very specifically that I'll be using YouTube live stream in order to share the video, because there are too many people in this class to use the screen share facility on Discord. So there you go. Yeah, so yeah, Obsidian is about the same. So whatever note-taking tool you want to use is fine. The key is take notes in class. Okay, that's really important. I think last semester I learned that some people do not do anything during a live lecture. They just kind of turn on YouTube and then they just walk away. I go like, how is that going to help? I have no idea. I simply cannot understand how that is going to help. Anyway, alright, good evening everybody, and I'm going to get started with this class. There are a few things that I have added to the Canvas presence of this class. These 3 things are just added. One is about aptitude and preferences. One is about attitudes, and the last one is about required resources. And I'm going to start with required resources here. This is not a part of the syllabus, but nonetheless, I think it is actually somewhat important. Because I think this first part here, what does 1 unit mean when you're taking a class in college? Okay, so I'm not just talking about ARC. This is the same kind of definition as in Davis, in UC Berkeley, in CSU, all the CSUs. What does 1 unit mean? Okay, that's the question. So the answer to that question is 1 lecture unit means 16 hours in lecture for the entire semester. And that, well, actually it's 16 hours in lecture and then 32 hours outside of lecture. This is per semester. Okay. So when you look at 1 week's time, okay, I did some calculations over here. So when we look at 1 week's time, it means outside of the labs, outside of the lecture, for a 3-unit class, people are expected to spend 5 1/3 of an hour per week to basically review the notes, okay, to study, to do the homework assignments, okay, to have a preview of the material that we're going to introduce in the next class, and so on. And that's 5 hours, 5 1/3 of an hour. That's in addition to lecture time and in addition to lab time. So this is the realistic expectation in order to, of what is considered, putting enough time in a class. All right. So Not sure whether people can actually do it or not, but that is the expectation, and I just want to make it very clear that most of the people who succeed in my classes do spend about that much time in outside of class time. And I'm just gonna do a quick one last scan of people on Discord. Okay, we got one last person that I'm catching right now, and one more. But that person has not changed the nickname to the actual name. The Discord name is Stella McNasty. Pretty sure that's not the actual name on roster, but I cannot keep scanning when I'm teaching a class, so I'm not gonna scan anymore. There we go. Okay, all right. Thank you, Aaron. That's good information there. Alrighty. So other resources, you need to have a space, right? So you need to make sure that you have a space where it is somewhat distraction free. It cannot be absolutely distraction free, but hopefully you can find a place where it is relatively distraction free. And you need structure. Structure means you need to have a specific time for for this class, and this is why I teach in synchronous mode instead of asynchronous mode, because if I teach in asynchronous mode, I'll be the first one who's going to goof off and forget to actually get my classes prepared. So I need that structure, and that's why I need to teach this class in synchronous mode. So there we go. Hello, Perry. Okay, so note-taking tool. Okay, so this is really important. It's very, very important to not only take notes, but take notes in the right way in a class. So I'm not going to get too much into note-taking because you can always Google your best practices in note-taking or note-taking for college classes and so on. So I would encourage you guys to find out what is the best way for you to take notes, because it's different for different people. All right. I'm on Discord. It's the YouTube link. It is already pinned, and this is what the announcement says. Yeah. There you go. Thank you, Vincent, for repeating that link. Oh, no, I have not taken roll yet. Okay, it is not at that time yet. I have randomly determined a time, but it's not there yet. Alrighty. So now that we got this stuff out of the way, the syllabus is not. I'm not going to spend much time to talk about the syllabus in class, because I would much rather spend class time to talk about class material. So the syllabus is in its own video. It's also sent to you guys by announcement. So I am just going to put one thing in the text channel here. Please read all announcements as they become available. There we go. All right. So in my classes, there are no stupid questions. So if you guys have anything to ask, go ahead and ask. Now, given that there are no stupid questions, there are questions that reflect, let's just say, a lack of reading the material and preparation. So I'll just put it that way, and I will respond to those questions accordingly. Alrighty. So now we're going to get started with the actual class content, because it's actually important for us to get started as early as possible, because this is going to be a pretty packed class in terms of material. And we're going to start with this: physical states, truth, numbers, and computers. So I'm just doing a right click here, and it goes to a specific module. This is way before we started to use Canvas. So my module is really just a unit of text material that I personally write for various classes. And this is 0281 simply because that's the sequential number at the time when I wrote this module. which is not this date because I have written this module a long time ago. Alright, so I am going to skip a few of these sections in terms of physical state, physical devices, physical state again. I'm going to skip section 2 simply because there's no way I can ask questions in section 2. It is for your own information. So for those of you who are curious, okay, for those of you who want to know, so what does a computer look like in the good old days before transistors, you can go ahead and read this for yourself, okay. So you can read what is a electromechanical computer. You can also read about how vacuum tubes used to be used in computers. You can also read about transistors, generally speaking, what it is, how does it work, and so on. But I can tell you, I'm not going to ask any questions about section 2. So it's mostly just for people who are curious. And then section 2.2 talks about physical states. So we are talking about voltages, we're talking about water, water pressure, and so on and so forth. So it's really not important, okay, what we use to make up the computers, because we only care about the logical operation of a computer. And so we're going to skip all the way to section 3.1, which is where the actual class content starts for this class. So we are getting back to transistors, but this time we're getting back into transistors that are very specific, and these things you're going to use in today's lab. So this is actually very practical because guess what? Your activity today during the lab time does tie into this particular section, section 3.1, that talks about transistors. So now what I'll do is I am going to switch to a command line interface, and I'm going to start up Logisim. And before I do that, I am going to show you guys how to get there. So please do not follow me, because if you are busy following me to get to the Google Share folder and try to get Logisim downloaded and started up, you're not going to be paying attention to me. So do not follow me, but what you might want to do is to put a timestamp in your notes, because if you can see at the upper right hand corner, right about here, is the actual clock. Okay, so you might want to just write down the time, so this way it's easier for you to find out, to get back into the video recording, so that you can say, okay, I need to go back to that section because Tech was showing us how to download the jar file and so on. The lab instructions actually include that as well, but if you want to have a secondary source of a demonstration, you can go ahead and do that too. So we get to shared folder, and then I just open a new tab so I don't lose track of the other one. And out of here, there's a file called logisim310.jar, and the extension jar is Java, Java archived, and that's why it's called a jar file. So in order to use this tool, which we'll be using for the entire semester, you need to get Java installed first. It should be installed on most computers already, but if you have a computer where Java is not installed, then you have to first install Java, and then you can make use of this file. To make use of this file, okay, I know most people like to click, but that's not what we want to do. We want to right click, and then we want to download the file. So when you download, most browsers by default will download to the downloads folder. And you don't have to do it that way. You can configure your browser so that you can control where your files are downloaded. That's a personal preference. It's entirely up to you to decide how you want your browser to download a file, or where it's going to download the file to. So in my case, it always asks me, do I want to open it or do I want to save it? So you probably will want to save the file. And whatever folder you want to save it to, that's fine. That's entirely up to you to decide where you want to save that file. So I got it saved in a particular folder already, so it's not a big deal. And we got some people typing in the text channel. I'm keeping an eye on the text channel while I'm talking to the screen here. Let me see if I can turn on my webcam and see if the problem is still there, whether it's still lagging. Yep, it's still lagging, way lagging behind. I'm not sure exactly why it is lagging so badly. So I'm going to turn it back off because otherwise it would just cause massive confusion. Alright, back to Logisim310.jar. Alright, so now we need to use it. You can always just double click on the jar file, and on most systems it's going to start it up just fine. Okay, thank you. So John just listed a YouTube video of going over physical states information. All right, cool. I haven't watched it. Okay, I have not watched that linked YouTube video, so I'm not really sure how much of that overlaps with what I have talked about. But I'm just going to continue with how to run Logisim. Now you can run Logisim in two ways. You can run it from the command line, or you can run it from the GUI. I think in Windows, most of the time you can just go ahead and you can just go ahead and run it from inside the GUI. You can double click the jar file and it will start up correctly. But eventually, you're going to have to start it up from the command line. So I'm just going to teach you guys how to use Logisim from the command line. Alright, so I'm using Linux here. If you're using Windows, you have to use a CMD, the command line interface of Windows. Whatever you do, in Linux is java-jar, and then we specify the path to that file. So don't worry, your lab and instruction actually includes, all of this stuff too. So you don't have to, busy copying or writing down all this stuff here. But if you want to, you can also, just kind of jot down the time stamp so you can get back to it, quickly when you're watching the recording. And I got one person who said, just got the name changed. All right, fine. I'm gonna change the name. Change the membership of that one person. So this is something that I would like you guys to kind of pay attention to. Is don't wait until the last moment. That really is not the best way to do things. So because I have been sending announcements for a few days now, and I was kind of expecting people to read the announcements as I send the announcements. So that's so from here on, I think I can now say, please read the announcements as soon as possible. Do not wait and wait and wait until after the class has started to read the announcements. Yes, so I was referring to Igor and a few other people. So anyway, now we specify the path, and this is the home folder symbol in Linux. Windows has a different way to refer to the home folder, and it's all in the notes included in the lab and also the assignment that goes with the lab. So you don't have to copy anything here. So mine is a little bit long, because this is where I store the jar file. And once I have entered the command line command, press the enter key, and this is Logisim. So Logisim starts up right here. And now we can do something with it. Okay, so the first thing I'm going to do, yeah, Mac OS should be about the same, if not identical to Linux. You just have to make sure that you have Java installed already on your computer. If you already have Java installed, it will be the same. It just depends on where you put the jar file. So there you go. All right. So first thing first. Okay, we're talking about transistors, right? In order to understand how a specific component works or how to do something, guess what? Logisim comes with its own help files. So they're basically all HTML documents. There's a tutorial. All right, so let me put this back into view. So this is the tutorial. The tutorial actually talks about a lot of things that we are going to also do. It talks about what is a sub-circuit. It talks about what is a library, and so on and so forth. So I encourage you guys to kind of find time to read the documentation if you can. But right now we are not interested in the tutorial. We are interested in the library reference. So when we get to the library reference, it would go to the wiring library by default, which is here. And within the wiring library, we can find transistor right here. And then when you click on transistor, it will give you a pretty long documentation of what is a transistor, how it works, and so on. And there are two types of transistors. One is called a P-type transistor, and one is called an N-type transistor. So instead of reading the text file here, reading the help file here, I'm just gonna explain it, as I construct a circuit. So once again, please do not try to do this at the same time when I'm explaining it, because most people cannot keep up with the speed that I'm explaining it. But it's all getting recorded, right? So you can, when you watch the recorded lecture, you can always pause and then do whatever you need to do, and then unpause and then continue with the steps. So do not try to follow me performing these steps over here. Alright, so when we want to, well, I'm not missing XP because I'm using Linux. And this computer is, it's about 3 years old. It's a laptop computer. It still has plenty of resources for what I'm doing. Anyway, so when we get to wiring, we are going to go to transistor. So this is how you put a component on the screen. Yeah, you can actually. I think there are specific distros, or GUI, the front end, to make Linux look like XP. But to me, it's like, what is the point, right? Anyway, I'm going to put a so this is important, okay? Because this is me trying to explain to you how do you place a component into your circuit. This area over here is where you construct the circuit. Look at this as the definition of a function. Okay, this is the detail of a circuit. This part over here is more like all the constructs that you can have in a program. So in this case, it's kind of like a box of parts. So I'm picking a part called a transistor. So it's a single click, not a right click, not a double click, not a drag, just a single click, of the component that you want. And then you move the mouse, not a drag, you just move the mouse onto the other side. And if you click on the other side, it will place the component onto the other side. So that's how you put a component from, that's how you instantiate an object from a class. You can look at these things over here as classes or types in programming, and then when you click on it and then click onto the other side, you're making an instance of that in what I would consider as the definition of a function, which is this area over here in Logisim. Alright, so I'm gonna not stop, but I'm going to explain what we are seeing here on the screen. So you can also see down here, this is the property list of whatever component is being selected. You can also see that we have multiple tools here. Most of the time you're going to use the pointing tool, which is the one that I'm using right now. It is the edit, selection, and add wire tool. This one here is called the poking tool. The poke tool is going to be useful later on, but right at this point, we are not going to use it yet. Alright, so whatever component you have selected using the pointing tool is going to have its properties displayed over here. And in this case, we have a P-type transistor because the type here is P-type. It is facing east, and the gate location is top/left, and it has 1 data bit. Now, everything in the property can be changed. It has its own drop-down box. So if you click on the drop-down box on type, you can select P-type or N-type. I'm going to stay with P-type for now. In terms of facing, so the facing here is facing east, so it allows the component to rotate at 90-degree stops. So we have north, east, south, and west, and by default it is facing east like this. The gate location is top/left. Now the reason why it is slashed is because at this point it is on the top. This is the gate right here. And the number of data bits, is 1, which means, this is not a shorthand of a whole bunch of transistors bundled, as if and be displayed as one single transistor. So we'll get back to the number of data bits in just a little bit, but right now we're going to be focusing on the P-type transistor. So I'm going to label this, using the text tool. This is the text tool. For the most part, you do not need to use the text tool. I'm using it only because I'm documenting the terminals of a transistor. So we already have talked about, how this one here is called a gate, which has a symbol of G. This one here is source, and this one here is drain. So the direction of this arrow here is always going from source to drain. Alright, so this is the key to differentiate which side is the source and which side is the drain, because the arrow is always pointing from source to drain. This one here is the gate. Okay, so there we go, here's the gate. So the big question is, okay, now that we know which terminal is which terminal, okay, we got a gate, we got a source, and then we got a drain, how does it work? Well, you can kind of look at this as a faucet, as a valve, okay? So the flow of something is going from source to drain, but the gate is where you have control over whether it's flowing or not flowing, so you can stop the flow. Now, the question is, how do we turn this on and how do we turn this off? Well, that depends on whether this is a P-channel transistor or an N-channel transistor. As it is right now, it is a P transistor. So let's get back to the documentation, which I think I have already got rid of. So let's go back there, go to help, and then you go to library reference right away. Okay, it's time to take roll. So the way I'm taking roll is kind of like this. Okay, I'm switching back to canvas right now. And the way I take roll is simply to give you, quote unquote, a quiz. So I'm creating a quiz right here. And it's not actually a quiz. The score does not actually become a part of your final score. And I'm going to call this quiz 2022-0118, which is today's date, roll taking. And it's going to go into a group called roll here. So this way it does not get into your actual score. It doesn't affect your GPA whatsoever. But people who have been missing too many classes will get dropped because of the lack of successful roll taking activities. So I'm going to add the item. And unfortunately, when I add the item, it adds it all the way to the bottom of the current module. So I'm going to have to, you can see that there's a whole bunch of previous ones, but this is the one that I just created. So I'm going to scroll it all the way back up so you can see it. You cannot see it just yet because right now it's hidden. Go all the way up. Alright, so there we go. Alright, so you cannot see it because it's still hidden. I have not published it. And now I'm going to actually construct the one question, okay, in the quiz. It's just for roll taking purposes. So I'm creating a question here. And what is the roll taking word? And I need to change this from multiple choice to fill in the blank. And there's only one blank here. Alright, so now I'm gonna get not so creative. I'm just gonna use Logisim as the answer. So Logisim, okay, I'm gonna put the roll taking word in the text channel too. So Logisim is the word. And there's only one correct answer. It's Logisim, all lowercase. I suggest that you guys just copy and paste from the text channel when you get to the quiz. So I have to remember to update question and then save it. Oh wait, I don't save it yet because I have to give you guys the amount of time to do this. So it's going to do in 10 minutes. Right now is January 18th, and the current time is 6 o'clock ish. So I'm going to give you guys up to 6:10 p.m. to participate. So right now, so that should be plenty of time. And then I click Save and Publish. So when you refresh your browser, you should see this activity, and it will ask you to enter a single word, and that one single word is in the text channel right now. It's Logisim. Just copy and paste it and then click Submit, and it should give you a score of 1, which means you have just proved yourself to be present. Good job, Harry. Well, I can actually see, the actual time, but I don't think it's important. Someone can be the last one, as long as it's before it is due. It will still be counted. Oh, okay. Well, just do the one for today. That's why the road taking activity has a date in it by itself. No, it's okay. You guys can just go back to the right one. Go back to the right one and enter Logisim, and it should be okay. Alrighty. 100%. Excellent. Okay, so I think we're done with that for the most part, and I am switching back to Logisim. Now, this is the library reference of Logisim, and we're going to go back to Transistor. And the way it explains this is it's using a truth table to explain a p-type transistor. So ignore the n-type for the time being. This is the p-type. So a 0 is a low voltage, a 1 is a high voltage, and X is representing do not know or not care, and then the Z means it is not connected at all. So what this means is if the source is a 1 and the gate is a 0, now that doesn't seem to make sense. Okay, maybe in the summarized form is better. Okay, there we go. So when the gate is a 1, then the drain is not connected to anything. If the gate is a 0, then the drain is connected to the source. In other words, the switch is closed. Alright, so let's go ahead and go back to Logisim and just play with this a little bit and find out how we can experiment with a specific component in a circuit. So let me switch back to this diagram here. Alright, so how do you test a specific component? By itself, you can't really do much about it. So you need to have pins. So these are pins over here. This is an input pin, and this is an output pin. The input pin is like a square, and then the output pin is like a circle. So I'm going to put an input pin over here so that I can connect it to the gate, because the gate has to be an input pin. The source is also going to be an input pin, so I need another input pin for the source. And then the drain is an output pin, so it's going to have an output pin over here. So now I need to connect the wires. To connect the wires, now this is the part where people really have to be paying attention, because I think a lot of people do not pay attention, and it shows when they turn in their files. Alright, so how do you make connections between components? Well, you kind of have to connect to very specific points. So if you hover your mouse pointer around, you can see that for the most part, it's just floating on top of the component. On the other hand, if you're floating on top of a connection point, it highlights it. So there are 3 connection points with a transistor: G, the gate, source, and then the drain, these are connection points. With an input pin, the connection point by default is on the right hand side or facing east. For an output pin, the connection point by default is facing west. So if you make a connection, okay, let me just try to make a mistake here so I can illustrate what I mean by people do not listen. So if I make a connection here, so this is just a drag operation, and then I put it over here. This is not a connection. There's no connection from the drain of the transistor to the output pin whatsoever, because the connection point of the output pin is right here. And this is really just part of the symbol of an output pin. It doesn't mean a single thing when a wire is just touching the symbol of a specific component. So do we have any questions about this part? And we got some people in the general channel. All right. All right, we got some questions coming or some comments coming, so I'm just going to pause here and wait for people to be done with typing. All right, so the first question is there a specific reason that is the case? I'm not sure what that is referring to. I'm guessing that is referring to there is only a specific connection point to a component. Well, some components have more than one connection points, like a transistor, right? So if you're just touching the component somewhere, it's ambiguous. Okay, which pin or which connection point do you want to connect to? So so I think it's for that purpose. The input pins. I'm not sure. Okay, so okay, when you're asking a question, try to avoid the use of pronouns, because I do not understand what they is referring to, or that is referring to, or it is referring to. So try to be specific when you're asking questions in the text channel. All right, so I'm going to undo the operations, so this time I can have it connected correctly. So to draw a wire between two connection points, go to the first connection point first, and then press and hold the left button on the mouse. So basically it's dragging, and when it gets to the other connection point, release your mouse, and now we have a connection, in this case, from the drain all the way to the output pin, which is nameless at this point. All right, so I'm getting back to the text channel. What are the O's for and the X for? What does it do? This is an input pin. It allows you to specify a value. This is an output pin. It allows you to observe a value. So input pins, output pins. You can look at an input pin like a regular parameter. It allows someone to pass a value from outside of a subroutine into a subroutine. An output pin is kind of like a pass by reference parameter. It allows a value to be observed by an entity that is outside of the circuit. So that's one way to look at it. Is there an easy way to validate that the connection has been made between two objects? The answer is yes, sort of. So if you move one of the object around and the connection moves around with it, then you made the right connection. So that's one easy way to confirm it. The second way is to use the poke tool. The poke tool is actually quite useful, so I'm going to change to the poke tool here. So this is the poke tool. Once you switch to the poke tool and you click on the wire, it will thicken, it will highlight itself, and it doesn't really quite show you, that the output pin is really connected to the wire at this point. So I guess it is not as helpful as moving one of the components around, and if you see the wire moving with it, that means you have made a connection between the two connection points. Alright, so there you go. Alright, excellent. Alright, so I am going to finish the connection here. Okay, so I'm going to connect it over here and this one over here. Alright, so now we have, now we can test the circuit. So as it turns out, if you're dealing with a p-type transistor, when the gate is at a low voltage, okay, when the gate is a 0, then the source and the drain are connected. So when I change, so with a poking tool, you can change the state of a pin. So right now, the state of the pin, input pin connected to the gate of the transistor is a 0, and the state of the input pin connected to the source is also a 0. But by switching to the poking tool, I can now change the state of the pin. So I can click on one of the pins here, and it changes the state. And you can see how, when I change the source to a 1, because the source and the drain are connected, so the drain is updated to a 1 as well. So let me pause a little bit here and see if there are any questions about what I just demonstrated. With a p-channel type of transistor, when the gate is a 0, it connects the source to the drain. Alright, I'm not seeing any questions. So now the question is, what if the gate is a 1? Because, I just said, if the gate is a 0, then the source is connected to the drain. So it kind of makes sense that, if the gate is a 1, then the source and the source and the drain would not be connected. So let's go ahead and make that, change the state of the input pin that connects to the gate so that the gate is now a 1. And now you can see how the source is not connected to the drain, and X here simply means that it is not connected to anything. In a circuit terminology, it is called floating, which means this particular connection is no one is telling it to go to a 0 or a 1. It is just kind of hanging around without a determined state. Alright, so we are going to, there's a question. So without the connection from the gate, nothing happens when you connect the source to the drain. Correct. Yes. So the gate is very important because this is how it's okay. So if you think about a normal switch, okay, go to a wall switch in your house. The gate is the little lever that you can flip up or down. And then this is the wire coming from from SMUD for most of you, and this is the wire that is going to the load, which can be a light bulb, can be a computer, can be something else. Okay, so that's one way to look at it. All right. So I'm going to do one more thing, because now that the gate is a 1, the switch is basically off. It is not connecting the source to the drain. So even if I change the drain to a 0, it doesn't change the state of. If I change the source, excuse me, I misspoke. If I change the source to a 0, the drain doesn't change at all because right now the source and the drain are disconnected. They are not connected in any way. So this is how a p-channel transistor works. So now let's go ahead and change the type of the transistor. And before I do that, I'm going to go to Simulate and Stop Simulation. So we can go to here and click on Simulation Enabled and just click it here. So now the check mark is gone, which means it's not simulating anymore. And I would even go to reset, okay, just so that what we see is not going to be confusing us. So what I'm going to do now is to change the type of the transistor from a p-type to an n-type. So to do that, you have to select the component first. So make sure that your tool is a pointer, and then you point to the transistor here and then just give it a single click. It will select the transistor as the component. And then once it's selected, you can look at all of its properties. And all we have to do is to go to type here, click on the drop-down box, and then change it to n-type. So instead of a p-type transistor, now we have an n-type transistor. An n-type transistor looks different from a p-type transistor, but only in a very minor way. A p-type transistor has a bubble right about here, and an N-type transistor does not have a bubble over there. And that's the only difference. Okay, visually, that's the only difference between an N-type transistor versus a P-type transistor. Perry is typing in the text channel, and I'm gonna keep an eye on the text channel. So that bubble is actually significant because in a circuit like this, a bubble means it's negated. Okay, so a negated means, in this case, means when the gate is a 1, it's turning off the switch. Because normally, when we think about on and off, 1 means on, 0 means off. But with a P-type transistor, when the gate is a 1, it's actually turning off the transistor. When the gate is a 0, it's turning on the transistor. An N-type transistor, which is what we have here, does not have a bubble, which means when the gate is a 1, it is connecting the source to the drain, and when the gate is a 1, when the gate is a 0, it is disconnecting the source from the drain. Alright, so Perry has a question. Without a connection from the P-type gate, the source connects to the drain. When the gate is connected to on, the source disconnects from the drain. So the gate should always connect to something. It would be a very bad circuit if the gate is left floating or not connected to a definite 0 or a 1. So with a P-type, when the gate is a 1, then the transistor is off, meaning it is not connecting from source to drain. When the gate is a 0, then it does connect from source to drain. And that's for a P-type transistor. This is an N-type transistor, because when we click on the transistor, it shows us that it's an N-type. So with the N-type transistor, it's the opposite. When the gate is connected to a 1, it turns on the transistor, meaning it is connecting from source to drain. When the gate is a 0, it disconnects from source to drain. Yes, so the gate is basically a switch, but the polarity of the switch is opposite when you're looking at a P-channel P-type transistor versus an N-type transistor. An N-type transistor is more quote-unquote intuitive because a 1 means on. A P-type transistor is negating the input or the gate, meaning that when you have a 1, it is actually turning off the transistor. Alright, so let's give it a try. So in order to see the effect of an N-type transistor, we have to go back and return on simulation. So now that simulation is turned back on, but because the gate is now a 0 and this is an N-type transistor, the source and the drain are disconnected. And that's why the drain is displaying an X, which means it's kind of like an unknown value. Okay, you can look at an X here as a uninitialized local variable, or the value of something that is uninitialized. So right now they are not connected. Now if I use the poke tool and change the gate from a 0 to a 1, then you can see how the source, which is currently a 0, is also reflected at the gate here, because now these two are connected. Now what I'm about to do next, the electrical engineer will look at this and frown, profusely, because with an N-type transistor, you're not supposed to put a 1, where the source is located. So I'll explain that in just a little bit. But you can also see, how the source, the state of the source is reflected at the drain, because the gate is a 1. So the gate is, as you guys have already stated, is basically the lever of a switch. So you can either switch it on, which means we are connecting these two terminals, or you can switch it off, which means we are disconnecting these two terminals. So are we doing okay so far? Do we have any questions about the operation of the two kinds of transistors? All right. Yeah, this is the part where it's kind of interesting how some people think the symbols in the circuit makes more sense than coding, and other people look at the circuit and go like, oh, this is not coding at all. I'm not liking this. So different people respond differently, when it gets to looking at circuitry. But it's still logical. Everything is still just kind of logical. It's all zeros and ones. It's not that different compared to programming. Alright, so now I'm building a circuit, which is also a circuit that you are going to build in your lab. So once again, you try not to follow me because it's all getting recorded. If you can see something in YouTube live stream, it means it is being recorded with my channel. So is this what most of the class is going to consist of, or part of this semester? We are going to be using Logisim the entire semester, okay? But at about midpoint of this semester, Logisim is going to run our processor. In other words, we're going to write some assembly language code to run in a processor that is running inside Logisim itself. So yes, so the idea is yes, we're going to use Logisim the entire semester, but we are not going to be constructing tiny little circuits like what we are doing right now, because at some point we're going to be simulating an entire processor using Logisim. Assembly language is very low level, but not quite at the bottom yet, as we will see later in the semester. All right. So I'm going to build a circuit here. It's going to use two p-type transistor and two n-type transistors. So I'm going to just take one transistor over here. And it's not exactly in the right orientation that I want, so I'm going to rotate it. So to rotate it, you have to change the facing. And I want this to face south. And I need one more of these. So to make one more, you can always do it the old-fashioned way, okay? The tedious way, which is going back here, make another transistor over here, and then rotate it, do whatever you want. But you can also do it the lazy way, okay? Well, I call it the lazy way, but it's actually the more efficient way. You can use the shortcut key Control D to duplicate. So there we go. So whatever thing or things you have selected, when you do Control D, it is going to duplicate it. It's going to make a copy of that. And now you can move the copy around, so it is, you can place it any way you want. So right now, the circuit still doesn't look the way I want it to look like. I mean, functionally, it is okay. It's just that, I would like to change the way it looks because I want this gate to be on the other side. So to do that, we have to change the gate location. Instead of left, okay, which is where it is right now, I am going to use the drop-down box to change it to bottom/right. So basically, this is just a mirror image of what it used to be. And we're going to need two n-type transistors. So to make an n-type transistor, I'm going to Control D again to make a copy of this one. And I'm going to drag it down here because that's kind of where I want it to be located. But I want the gate to be on the other side again. Actually, no, I take it back. This one needs to be an n-type transistor, so I'm going to change the type first. And I want this to rotate 180 degrees, so it is going to be facing north, like that. I will explain this in just a little bit, and I want the gate to be on the other side too, so I'm going to switch the gate location back to left in this case. And I will need one more of these n-type transistors, so Control D is going to make another copy of this, and I'm going to position this one right about here. So I'm gonna just be a little bit fancy and move things so that they are more or less symmetrical. Okay. All right. So I'm just checking the text channel. I forgot that I turned off my webcam already, so you guys cannot see that I'm actually looking sideways to the text channel. So I'm gonna connect these two together, and then connect this one over here. And you can see how there's a little dot over here. The dot is significant. Okay, if you see a dot, that means everything going into the dot, they will be physically connected in real world if we were to actually make this circuit in real world. So I'm going to show you a crossover in just a little bit where you see the wires kind of crossing each other, but if there's no dot, it means there's no actual electrical connection. So once again, we have an electrical connection here, and then I'm going to connect this one to here, and then this one to here, and then this one to here. So this symbol over here is called power. You can kind of look at this as another way to specify a 1. Okay, So power is kind of the same thing as a 1, and this one here is called a ground, which is kind of the same thing as a 0. So this is just a kind of more electrical way to specify a 1, and this is a more electrical way to specify a 0. Alright, so the circuit is almost done. So you can see something is in red here. So in this case, red means we are not really sure what it is. Okay, just because we don't know the state of the transistors, because you can see the gates of all 4 transistors are not connected to anything yet, right? So that's why this particular circuit says, that's why Logisim is saying, I cannot tell you what this particular wire is supposed to be, because we don't know the state of the transistors whatsoever. Now, this is the important part here. The important part is the source of a p-type transistor should always connect to a high voltage, and then the source of an n-type transistor should always connect to a low voltage. So this part here is it's not a logical thing. It really has to do with the device physics of transistors. So if your major is going to be electrical engineering, you will learn that eventually. On the other hand, if your major is in computer science or even computer engineering, you probably will not get into device physics, to understand why the source of a p-type transistor always has to connect to a high voltage, and the source of an n-type transistor always has to connect to a low voltage. But you have to observe these rules when you're making your circuit, otherwise it's not going to work. Are we doing okay so far? All right, excellent, thank you. All right, so now what we're going to do next is we are going to hook up some pins. So you're going to say, well, we're going to use these input pins and output pins. Yes and no, okay, sort of. So we're going to pick up a single input pin here, and we're going to make this a multi-bit input pin. So by default, a pin only has one single data bit. We're going to change it. So we're going to change it to 8 bits. And you're going to say, but we don't need all 8 bits, do we? You're right. We don't actually need all 8 bits, but that's what your homework assignment or your lab is going to require you to do. So I'm just replicating what your lab needs to do, so that this way you can kind of refer to the demonstration in lecture when you're doing your lab. Alright, so there are 8 bits over here, and then we're going to specify an output pin on this side, and we're going to specify 8 bits too. So the idea of using 8 bits for the input pin and 8 bits for the output pin is not really so much that we need all 8 bits. It's just that this gives me a more or less universal input pattern. So this way I can reuse the same circuit tester in order to grade whatever circuit you turn in. Alright, so I'm just moving things around a little bit here. Totally insignificant over for that part. Alright, next thing we're going to do is to say, I'm going to need to connect from the input pin to the gates over here. So we're going to have these 2 transistors to be connected, or the gates of these 2 transistors to be the same. And we want this gate over here and this gate over here to be connected as well. So we're going to do something like this. Okay. Now, the important part is when we draw this wire, we don't want to stop over here. Okay, so we want to drag it all the way directly over the other one, like so. Oh, okay. It's still connecting because the this is actually where the connection pin or the connection point is for this n-type transistor, and that's why it did not work. Alright, well, so what we're going to do is to move this transistor down, so that will give me the clearance that I need. Like this location here is not the connection point of either transistor. So now we have a point where we can fly over the other wire. Why not flip the gate? Sure, we can do that, but I want to show you guys what it means to be flying over. So let me show you that first, and then we'll do the better approach of flipping the gate. So once we are here, as long as we don't stop at this point, we're going to have a wire that is flying over like this. So you can see this intersection here does not have a bubble like this one over here. That means this wire, the one that is going in horizontal direction and the one that is going in vertical connection, they are going over each other. They are not conducting. They're not connected as conductors. So I want this one to eventually kind of connect to here. Well, the reason why I do not want to flip it is because I need both to connect to the input pin. I can always kind of go around like this. That works too. So right now, so let me go ahead and introduce the term node, N-O-D-E, node. So this is one single node. Okay, it's basically just a single conductor that turns out to connect to the power and also the source of both of the p-type transistors. So this is called a node. A node is basically electrically the same connection, but it might connect multiple pins of multiple components. And then this is also a node right here. So this node here is connecting the drains of both of the p-type transistors to the source of this specific n-type transistor. So that's the term of a node. It is a single electrical connection that can be attached to multiple points of different components. So what I want to do now is to say, well, out of these 8 bits here, I want one of them to connect to this node, and I want another one, this one over here, to connect to this node. So if you try to make a connection like this, it's not going to work. But I will show you how it is not going to work, because you might see that message. So what we are seeing here is incompatible widths. This is the error message. And you probably can guess what it's trying to tell you. It's trying to tell you that this pin, this connection point here, has 8 individual bits. This connection point over here only has 1 individual bit, and that doesn't work. Okay, because now you're trying to stuff 8 individual bits into one single bit. How are we going to do that? We cannot. So we have to undo this. So now what we need is a splitter. So if you go back to wiring, the first item is called a splitter. So I'm just going to put a splitter somewhere in the circuit because I want to explain what it is and what you can do to control that, what you can configure with a splitter. So a splitter has a phasing, so you can rotate it around, and the phasing is always referring to the side that has the split end. The second one and the third one may seem confusing. Fan out is saying how many split end does it have. But bit width, on the other hand, is trying to specify on the merged side, how many bits are we trying to specify. Now, because the merged side is supposed to connect to the connection point of the multi-bit input pin, so we need 8 bits for the bit width over here. And because we have a fan out of 2, Logisim will automatically say, hey, we got 8 bits of the merged end. There are 2 split end. Let's just even split it. Okay, so we have 4 bits, 0 to 3 going to the top split end, and then we have bits 4 to 7, also 4 bits going to the second split end. But that's not what we want, because if we did it this way, then this connection point also has 4 bits. We just need 1. Okay, this is just 1 single bit. So this is not going to work either. So at this point, what we will need to do is to look at all the individual bits over here, and each one has its own drop-down box. So let's see what is in the drop-down box here. So for each bit, okay, from the merged end of a splitter, for each one, you can select one of these 3 options. You can say it doesn't even come out of the split end of any split end. Yeah, that's perfectly okay. Or you can say it comes out of the top split end, or you can say it comes out of the bottom split end. So you have 3 choices over here. Now, we only need 2 bits. Okay, we only need bit 0, which is this bit over here, and bit 1. So the other 6 bits we really do not need to connect to the split end at all. So starting with bit 7, I'm going to say none, 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 okay, none, none, and none. So right now, we only have 2 bits that are connected, but they're both connected to the top split end, which means the bottom split end is not connected to any of the bits from the merged end. Okay, well that's not what we want, because we want bit 1 to connect to the bottom. There we go. Alright, so that looks a lot better. And I just want to make sure that the way I split this is the same way as what you need to do in your lab. So I'm gonna take a quick look at the lab diagram and make sure that I'm not mistaken when I am working on the demonstration. So let's see. Alright, so yeah, so bit 1 connects to this one and bit 0 connects to the other 2. Okay. Well, the circuitry is supposed to be symmetric, so it really should not matter in terms of the correctness of your answer. But, I just want to be as consistent as possible. Alright, so now we can put it over here. And then make a wire connecting from the 8-bit input pin to the merged end of the splitter. So why even have 8 bits? Well, just because some of the other circuitry will also need multiple bits. I'm just too lazy to redesign the circuit tester, so I want to have one single circuit tester to work on all the circuitry that you guys will be working on. So that would be the answer. So the answer is me being a little bit lazy, not wanting to redesign the circuit tester, for different circuits. That's about the right answer there. All right, so we have one bit 1 connected to the left p-type transistor and the top n-type transistor, and then we're gonna have bit 0 to yeah. This is not going to look very nice, but that's okay. As long as logically they are connected in the right way, it will still be okay. And what about the output pin, right? So we only got one output coming from this circuit. It is this node here. Let me highlight the node. This is the output of the entire circuitry. So in other words, the input, there are 2 inputs. We want to dictate the state of this gate and this gate. They are the same. This gate and this gate, they will be the same. But then the output is just whatever this node is experiencing. That would be the output. So what we're going to do is we use a splitter again, but this time, when you look at a splitter, you can look at this as a merger. So first of all, we have to rotate it. Okay, so we have to rotate it so that it's facing west, and we have 8. It's an 8-bit splitter. It's an 8-bit splitter, not 9, 8. Okay, so I said 8, but I accidentally clicked on 9. It's an 8-bit splitter because the output pin here has 8 bits, even though we're only using 1. As I explained a little bit earlier, I'm just too lazy to have to redesign the circuit tester. So here we go. We have 8 output bits, even though only 1 is reflecting the state of this specific node. But we only need 1 fan out. Okay, so the fan out ratio is going to be just 1 because we only need 1 bit of the 8. So now we have one single split end. And of all of these bits here, bit 1 to bit 7, they don't need to connect to anything. So they will all be none. Like so. And when you look at the diagram, when you look at the splitter, it means this is the symbol is basically telling you exactly what it's supposed to do. It is only taking one single bit, which is bit 0, and it's going to merge it with 7 unknown bits to the merged end, and then the merged end is going to connect to the output pin right here. So that is the circuit you're supposed to build. Once you have built the circuit, we can test it. So we got a question. So why do you use 2 bits for the left side and only 1 bit for the right side? because we have to control this gate and this gate as one of the input, and then we have to control this gate and this gate here as the other input. This 0 here, this is bit 0. Bit 0 is connected to this node. Okay, let me switch back to the poking tool. So this node here is bit 0 of the input pin. This node here is bit 1 of the input pin. So we have two inputs, and then we have one single output, which is this node here. So is that answering the question, Bilal? If I butcher your name, just let me know, because I cannot tell whether something is supposed to be a short I or long I just by looking at it. Okay. Oh, okay. Gotcha. All right, so now we can actually test the circuit. Okay, so if I put a 1 over here instead of a 0, so now you can see. All right, so let's try to see what is happening here. Okay, let's try to explain why the output pin is a 1. So this 1, which is going to bit 0, is telling this transistor to turn off, and it's telling this transistor to turn on. Because the same 1, okay, let me use the poking tool right here. So this 1 is going into the gate of this of the P channel P-type transistor over here. Remember, with a P-type transistor, you can see with the bubble, if the gate is a 1, it is disconnecting. So that means this 1 here is not connecting through here. Then you might be asking, but how come it's light green also? I'll explain that in just a little bit. But this transistor is actually off. Okay, it's not connecting anything. But the same one is also connecting to the gate of the bottom N transistor. So the N transistor is actually turned on because when the gate of an N transistor is a 1, it's connecting from source to drain. So this transistor is actually connecting the ground, which is a 0, to this node here, which doesn't have a name. I click on the wrong wire, so there we go. That's the node that I'm referring to. So what about the other two transistors? Well, let's take a look at what the other two transistors are supposed to be doing. So this node here is connecting to the gate or the gates of the other two transistors. So the left P-type transistor now has a gate that is a 0, and because this is a P transistor, when the gate is a 0, it's connecting from source to drain. That is why it's connecting from power to its drain, which is the pin that we are trying to observe using the output pin. But this 0 is also connected to the gate of the top N transistor. Now with the N-type transistor, when the gate is a 0, it disconnects from the source to the drain. So that's why this particular transistor is as if it is not here. Okay, it is not connecting from this end to this end over here. So what does that mean, right? This transistor is off, this one is on, this one is on, and this one is off. So what it boils down to is when you look at the top part of the circuit, these two transistors are connected in parallel, which means even if one of them is turned on, we have a path from power, which is a 1, going to the node that is being observed by the output pin. The two N transistors are connected in series, which means if one is off, then the whole thing is off. So in this case, we have one transistor that is off, and that's why the ground, which is a 0, it cannot connect itself to the node that is being observed by the output pin. So that is why the output pin is observing a 1, because it finds one single path through this transistor to the power, which is a 1, but it could not find anything going to a 0. So is that okay? Are there any questions? Mark is asking a question in the text channel, so I'm going to wait a little bit. So the 2P are kind of like an OR, and then the ends are kind of like an AND. Yes, so that's one way to look at it, but I wouldn't call it an AND versus an OR, but there are similar properties, between the two switches that are connected in parallel versus the two switches that are connected in series. When they're connected in series, it does convey more or less a sense of a conjunction or an AND. When they're connected in parallel, they're kind of like an OR. So that comparison is valid, but I wouldn't call it AND versus OR, because the truth table is not the same. All right. So Bilal is typing. So while Bilal is typing, I'm going to switch this also to a 1. Oh, okay, there we go. We have the question. How do we differentiate which gate is a P and which one is an N? Well, we talked about this a little bit before. And if you observe the picture, can you observe any differences between the P-type transistor versus the N-type transistor? Just visually, are there any differences? The top two are P-type, and then the bottom two are the N-type. Yes, the bubble. With the bubble, it is a P-type. Without the bubble, it is an N-type. So this is why you need to take notes. So I'm kind of expecting people to kind of jot down some notes. When there's a bubble, it is a P. When there's no bubble, it is not a P. All right, the N-type. All right. Yep. Okay. Very good. And with a bubble, it is negated, and without a bubble, it is not negated. So when it's not negated, a 0 is off, a 1 is on. When it is negated, a 0 is on, and a 1 is off. Alright, so let's go ahead and change the circuit a little bit, or change the input pins a little bit, change this 1 back to a 0. So you have to make sure that you're using the poke tool to change the state of one of the inputs. So we change it back to a 0, and now the output is still a 1. What is going on here? Well, as it turns out, because now both P-type transistors have 0 as its gate value, so both P-type transistors are on. So now we have two paths going from the node that is being observed, and they're going through two parallel paths to connect to power, which is a 1. And that's why it is observing a 1, and we do not have any transistor turning on at the lower half of the circuitry. Yep. So how do we turn this output to a 0? How do we make sure that we have a path completed to go all the way to ground here? Well, I think you guys can probably. So this is troubleshooting. Okay, so I'm trying to introduce concepts that I think you will need for any kind of job in computer science or computer related industry. So we are trying to solve a problem here. The question is, how do we get an output of a 0 over here, which means how do we make this particular node a 0? So in order to make this a 0, we want 0 path. We don't want any path to connect to power, but we want a path to connect to ground. And because the two N transistors, this one and this one, they're connected in series, so we need both N transistors to be on in order for this node to find a way to connect to the ground over here. Are we doing okay so far with that analysis? All right. Thank you. Very good. Now, this is important because I'm trying to explain, the process of problem solving, right? Because we want to achieve a particular objective. So the question is, how do we map the circuitry that we have just built to the concepts that we have learned up to this point? So the point is, we want this node to connect to this node over here. In other words, we want both of these transistors to be on because these two are connected in series. Now, how do we turn on these transistors? They are both N-type transistors. So to turn on an N-type transistor, we need this gate value to be a 1, which also means bit 1 needs to be a 1 over here. But we also want this gate here to also be experiencing a 1 because that's how we turn on the other N-type transistor. So we want 1, 1 as the input in order to change the output to a 0. So now we're gonna give it a try. Okay, so flip this one to flip that 0 to a 1, flip that 0 to a 1, and we have just achieved what we set out to do. So again, this process is problem solving. We are looking, we have to identify what we want to do, what we are given with, which is this circuitry here, and then we are trying to figure out, okay, so how do we achieve that particular objective? We have this circuit here that is connected in series. We need both transistors to be on, but how do we turn on the transistors? Earlier, we talked about how N-type transistors are turned on when the gate is a 1. Okay, so that's how we problem solve and figure out that having an input of 1, 1 will change the output to a 0. All right, so what else is important here? The directions are important. The P-type transistors, they need to the arrow needs to go in this direction because the source needs to connect to power, and then the drain connects to whatever you want the drain to connect to. The N-type transistors need to face in the north direction because the source of an N-type transistor needs to connect to the low voltage. So that's why the arrows of the transistors are important, as are the bubbles of the transistors. Alright, so we got a question in the text channel. If there was a path from both the ground and the power to the output, that is a very interesting question. Okay, so let me see if I can build a circuit just to do that. Okay, so that's going to be interesting because we are trying to we're trying to build a circuit where it will connect to both, right? It's not going to be that easy to build that circuit, because I think in Logisim I can do it, but in real life, it's not that easy. But to answer the question, if this particular node here, okay, let me highlight the node. If this node is simultaneously connected to power and ground at the same time, that means power and ground are connected, right? So when power and ground are connected, you are basically looking at a scenario of shorting the terminals of your of the 12-volt battery of your car. That is the scenario when the power and the ground are connected. So can someone tell me what happens when the two terminals are shorted and you're talking about a car battery here? Okay, first of all, disclaimer, okay? Never ever do that, okay? I have to emphasize that. Yes, things will melt. I have seen puddles of things when people accidentally short out the terminals of a car battery. Yes, very bad things. Yep, because sometimes you can end up welding the clamp or whatever wire to the terminal of the battery. So even if you want to disconnect it, you cannot, and it's going to be really hot too. So you're not going to touch it, but sometimes it gets welded onto the terminal. So and all that energy is going to heat up the fluid inside the car battery. Usually that's a lead acid battery, and that fluid is going to boil, and it's going to it probably will just vent and not explode. But if it's a sealed battery, there's also a chance of exploding. So do not do that. Never connect the two terminals of a battery together. Yep, that's dropping a wrench on it, that would be bad too. Very, very bad. Anyway, I have just illustrated how to construct the circuit that you have to do in your lab, and we just ran out of time in the lecture, so we are transitioning to the lab right now. So let me open up the lab and the assignment that is associated with the lab. Alright, so let me go back to details. Alright, so I'm going to go through the settings of the lab for you with you. I'm shuffling the answers. I'm allowing multiple attempts, and Canvas is going to keep the score of the attempt that is the highest. So this means, if you try it once and you didn't quite get everything right, you can do it again, okay? And it will just keep the score of the attempt that has the highest score. Let students see their quiz responses. Let students see the correct answers. But I'm not going to show the correct answer until, this is the wrong date, by the way. I will show the correct answers at when it's due, which is 9:50 p.m. today. So you got what, 3 hours to do it? That's a lot of time. Goes right for the system files. Show one question at a time. And this is also important. Logisim is the access code. I will type that in the text channel. So when you start this activity, once I publish it, you're going to have to enter the passcode, which is just Logisim itself. And it is assigned to the entire class. Save and publish. Alright, so so don't go ahead and do it yet, okay, because I still have to explain there's one additional step. So that's one of the things that you need to do, and this one is due at 9:50 p.m. tonight. But there's one more thing you need to do. At the very end of this lab, you will have constructed a circuitry, kind of like the one that I have constructed. So please do not ask me to upload the circuit that I have just constructed, because that's exactly what you need to do. I'm not going to upload it. So you're going to construct yours, and you're going to upload yours with this as a companion assignment. So with this companion assignment, I'm not going to ask you to turn it in tonight. I will give you a little bit more time to turn this in. In fact, I am going to let you turn it in right before class on Thursday. So that's plenty of time. So I'm going to make this due on the 20th, right before class, so 5:30 p.m. So the question is, why am I giving you this extra time? It doesn't seem to be needed. So I'm going to explain that, and then you guys can go ahead and do it. So this is a change from last year's assignment too. So for people who have done it before, the instructions are about the same, but I'm also giving you the exact instruction of how you can test your circuit. So I didn't quite go through the entire thing. But if you look at data in is corresponding to the input pin of the circuit that we have constructed here. So when both inputs, when we have 1, 1 as input, the output is supposed to be a 0. If at least one of these two bits is a 0, then the output is supposed to be a 1. So let me just illustrate it so you can see how the output is now a 1, and the output is also a 1, and the output is still a 1 over here. So that's how the circuit tester is going to test your circuit. Your circuit has to do this. And one more thing that's kind of important. I need this entire thing to be packaged as a chip. So you might think, oh no, that's going to be an extra step that we have to do. Not really, okay? So if you switch from this view, which is kind of looking at the definition of a subroutine, to this view here, this view is called Edit Viewed Circuit. Okay, you can also switch it from up there somewhere. So you're changing the subcircuit appearance. Okay, that's what the text is saying. So as soon as you switch over, it's going to look like this. It's fine, okay? The default way is fine. Just don't change it. As long as you just leave it alone, you'll be fine. Just don't change it, okay? Because this is kind of like the prototype of a function. It kind of defines where we want the input pin and where we want the output pin. Just don't change it, okay? If you leave it the way it is, you'll be fine. If you move it around, then my test circuit may not be able to work with your design. And then the last step is to save the file. So go ahead and save the file. And when you save the file, it will automatically has a CIRC or circ extension, and save it to a place you can find it so you can upload it later on. And that's about all you have to do with the lab. So please read the instructions very carefully, okay? Because if you send in the file with the wrong name, my script for grading this particular lab may not work. So you want to make sure that you observe all of the details. So there's a little bit of instruction here, and that's why I do not want to make this part due tonight, because I really want you guys to have a chance to run the test circuit on your own circuit. So this way you can kind of tell how I am going to grade your circuit, and it also prepares you, in the near future, so you can actually test your other circuits too. So this is why this part here, where you turn in the file, is actually due right before class on Thursday and not tonight. The other one, which is mostly multiple choice questions, that one is due tonight. All right. So do we have any questions? If there are no questions, then I can go ahead and turn off the live stream. Then I walk away, get something to eat, and then come back to answer questions while you guys are doing the lab. So I'm just going to wait for you guys to say whether there are questions or not. If not, I will stop the live stream at that point. I got several people typing. Okay, everything sounds good. Cool. Now, I also want to point out, if someone does not want to use the class channel to ask questions, for whatever reason, you can always direct message me, and I will go ahead and check my direct messages and answer questions without naming the person who sent me the question. So for whatever reason, if you do not want to ask questions, in class, you can always direct message me with your questions. I just want to make sure that people understand that option is available. All right. Can't see the assignment that's due today. All right, so let me show you guys where to find it. It's right below the topic, the module that we talked about today. So let me switch to student view first, because now it's going to show exactly what you should be seeing. So we just talked about physical states, truth, numbers, and computers, or a good portion of that. We are not quite done with it, but we are done enough so that you can get started with your lab activity. So your lab activity is right here. It says lab, Logisim Setup. So this is the part where you have to do tonight. You have to get it done by 9:50. This is the one that you have to get done by Thursday, right before the lecture. So I hope this answers that question. And then Bilal said, just to reiterate, multiple choice is due today. Yep. And the testing of the circuit is due before lecture on Thursday. Yes, that is correct. I thought we had to work out some of the making the circuit tonight as well. Yeah, for the most part, you'll be working it out, but you don't need the circuit to be working 100%. to answer all of the questions. Okay, some people actually would answer the questions in the lab portion in a very self-defeating way, but nonetheless, it does show that they can get full points for that. But the one part that is due on Thursday, is the actual useful part, okay? Because I want you guys to really build the circuit and be able to test it before you turn it in. And that's why there's a difference between the lab that you're supposed to do tonight versus the circuitry that you're supposed to turn in on Thursday. But Bilal is correct. If you follow the instructions of tonight's lab, at the end of that, you will actually end up with the circuitry that you have until Thursday to turn in. But I do want you to have the time to test that circuit using the method that I am outlining in the assignment. So that part may take a little bit more time, and that's why I don't want it to be due tonight. All right, so Tam said, I was looking to add the course since I'm on waitlist. Um, I will find out how many people did not successfully got the role taking activity done tonight, and those people will be dropped. And when there's vacancy, I will start to send permission numbers to people on waitlist. Yes, so the same thing for Owen. Okay, so I'm just gonna check, how many people, did not, were not here by role taking activity, standard, and drop those people. And I'll just be moving people from waitlist into the class by sending those people, permission numbers. But meanwhile, people on waitlist can participate in all the activities like everybody else. So please do that. All right. Yes, the quiz is there's an access code, and that's why I put it in the text channel earlier. Alrighty. My mic is crapping out. I need to resolder a connection. Yep. So Will, next time please pay attention in class because I gave that code out earlier. All right. So I got a private message. Oh, okay. That has nothing to do with this. Okay, never mind. All right. So it would appear that there are no further questions that I need to keep the live stream open, so I can close that. Okay. All right, so I'm gonna close the live stream now, and then I'm gonna go away, get something to eat. I'll be back in about 10 minutes. So I will be back in 10 minutes. And you guys can kind of stack up the questions if you have any questions. And that's it. All right. So I will actually, have a video, contact with you guys on Thursday, but I'm going to stay online until 9:50 p.m. tonight.